Hello guys, this video is to implement amortization calculator with a payment schedule and a pie chart. I have made similar video in object-oriented programming. You can view one of the video there. Agenda. Object-oriented solution for the loan calculator using graphical user interface in JavaFX, Java Swing, C#, and VB.NET. There will be 4 different videos for each of the programming language, Android and WPF sometimes in the future. So the classes I am going to use: loan class that will handle the loan calculations, payment class that will represent the monthly payment, and loan class will have the list of these payments for the number of months the loan based on the loan duration. The UI interface to facilitate inputs and outputs. The outputs will also be shown as a pie chart that will include total payment and capital payment and interest paid, and a table for the monthly payments. So we will learn following components. For JavaFX, we will learn TableView, PieChart, TextFields, labels, and FXML. For the Java Swing, we use TextField, JLabel, JTable, and JFree charting library. For the C# and VB.NET, we use text boxes, label, button, data grid, and also charting tool for the pie chart. Thank you guys. Hello guys. I have created Maven project for JavaFX. I am using JDK 17 and Scene Builder for the JDK 17 JavaFX, and I have set up the basics of the program. So I have set the size of the scene to 800 and 400 and created an empty Java FXML file that I am going to set up using Scene Builder, and our controller is empty and I will write everything from scratch. So let's begin. First we design the UI. Okay, empty. This is anchor pane. Okay, let's set the size, layout, and set it to 800 and 400. Okay, that will be sufficient space for our components. Okay, let's place an let's say a simple pane for over here. Let's put some bigger label for the introduction. Okay, let's say loan calculator. Let's increase the size and set it to 36. Make it bold, and that would be enough. Center it. Okay, now expand it. This would be enough. Okay, now label, and this will be enter amount and a text field. Okay, Let's copy paste. We need 3 input fields. Okay, so let's name them so they can be referenced. Okay, let's set the ID to identify it. TXT amount, TXT interest rate, and this will be TXT duration in years. Okay, now the button. Let's call it calculate. Okay, copy paste. Another button, let's say to exit. Set IDs btn exit and btn calculate. Okay, now we need a text field for output, and this is second, and let's make it bold. To make it prominent, and let's increase its size to 14. Okay, another set. Okay, so this will be for monthly payment, and this one for interest paid and total paid. Okay, we don't need the text. Let's set IDs first. LBL payment. This one will be LBL interest, and this will be LBL total. Okay, let's remove the text. Okay, so that's it. These are the components we need, and let's add chart. PieChart. Okay, I think this will be good. So let's name it and title loan chart. Let's say pie chart and layout 800 and 200. Okay, that's good. Okay, I think we are set. Let's save it. Save. Okay, now we will add the logic to work. Okay, now the ID. Okay, so first of all we need to set the FX IDs. Okay, FX ID TXT amount, FX ID. FX ID is needed to identify or reference these fields from the controller. TXT interest rate and FX ID TXT duration. Now we need buttons. Okay, FX ID btn calculate and FX ID for btn exit. we can ignore. Good practices, we should manage it. If we may need to change their text just in case, like we are implementing multi-language application. And this is just a tutorial, so I'm not adding the FX IDs for the labels. So the labels we need to output because we are going to access them. LBL interest, and we need this one, FX ID LBL total, and one more to go, and this is PieChart, and we need one more label here, LBL payment. Okay, now declare them inside the controller. Okay, at FXML private label LBL interest, and just copy up to this, so we can just add the name LBL total and LBL amount, payment, I think. Let me check. Payment. Okay, now two buttons, button btn calculate, similarly copy to save typing, and btn exit. Now text fields, text field txt, copy this and put the names LBL amount and LBL duration, sorry, txt, and txt interest rate. Let me check the name. These names must match with the FX ID. txt amount, txt interest rate. Okay, now PieChart. PieChart. Okay, now we need a function to execute when the button is clicked. At FXML private void handle exit. So just exit it, system.exit, and next FXML private void handle calculate. Okay, this is where we implement our logic. Okay, now associate the function with the buttons. On action, pound sign, and the function name. On action, pound sign, handle exit. Okay, our buttons are linked now with the backend functions. Next, let's add two classes, Java class, loan. So this is our entity class that will manage the loan. Class payment. Okay, this class will manage our payment. 1 minute. Okay guys, we are going to implement payment class. The fields we need: private int month, private let's say double, let's say old balance, private double monthly payment, or let's say payment, private double capital paid, private double remaining. Okay, this will show month start and old balance payment, and one thing is left, I think, private double interest paid. Yes, interest. Okay, for safe side, let's just create constructor from the code, generate and constructor, let's say this one, and parameter constructor, code, generate and constructor, and select all. Okay, and next just getters and setters. To save time, generate them from IDE, all of them. Okay, our class is complete. Okay, now loan class. Okay, private int duration. This is years. Private double IR, that is interest rate. Private double capital amount, or say amount. Okay, default constructor, and we need parameter constructor 1, 2 and 3. Okay, now let's say a utility function to calculate the monthly payment. Public and double calc payment. Okay, let's take amount, and let's take double rate. This is monthly rate, monthly payment, monthly rate for month, return monthly payment. Okay, this is standard loan payment calculation formula. Return rate multiplied by amount and divided by 1 minus math dot power and 1 plus rate and power minus months. Let's take months as a parameter, int months. Add it here, add param months per duration. So that is our standard formula. Rate multiplied by amount divided by 1 minus math dot power 1 plus rate and minus months. This will calculate our monthly payment. Now build the amortization table. Void build table. Okay, function to build loan schedule. Okay, we need few things. Private double total interest, private double total paid, Okay, now list payment and payments, new array list, and same here, and these to default, total interest 0, total paid 0, and total interest 0, total paid 0. Okay, now do the magic here. Calculate monthly interest rate. So double monthly rate is equal to IR divided by 12 and divided by 100. Now months, int months is equal to duration multiplied by 12. Okay, now we calculate monthly payment. Double payment is equal to calc payment. So monthly rate and months pass to the function. Now we need balance and other calculations. Variables. Double IR payment, and we also need amount paid and the new balance. Okay, we loop for number of months. For int month is equal to 1, month is less than equal to months, and month plus plus. Okay, first we calculate the IR paid. IR payment is equal to balance. Let's say we set the balance here. Double balance is equal to amount, so that our amount should not change during the processing. Balance multiplied by monthly IR. This is our loan interest payment. Next we will calculate amount or capital paid. Amount paid, that is monthly payment minus IR paid. This is our capital paid. Okay, next we need new balance. So new balance is equal to balance minus amount paid, because we subtract the capital paid in this step. Let's say step 1, step 2, and this is step 3, new balance of capital amount. Step 3, these 3 calculations are vital. Okay, next we need to create payment object to store it. So payment object is equal to new payment. Okay, first we need month. Next we need to pass monthly payment and interest paid, IR payment, and we need to pass amount paid and new balance. I think we need balance here. Balance. These are 6 parameters. Okay, store into the list payments dot add payment. Okay, I think this will work fine. object. Okay, now keep track of IR paid. So this dot total interest plus is equal to IR paid. Okay, calculate total paid. So total paid is amount plus IR, total interest. So these are our calculations that are done. Now we will use these payments, calculations, and we add the getter functions. Generate getter. Okay, we need one for duration and IR and amount. Yes, no, we don't need for them. Total interest, total paid, and the payments. Okay, 3 getter functions. Okay, now we go to controller. Okay, first parse the values, try and catch exception. Okay, in the we will display an alert message. Let's say private void alert user, and let's say string message. So alert is equal to new alert. Okay, 1 minute, hold on. Okay guys, so we need to show the error message. So alert type dot error. Okay, let's set message alert dot set content message and alert dot set title, and that is error message, and show it. And there, we don't need to wait for it because we just want to alert the user and notify him. Show the message for the error if invalid inputs dot get message. I think it is enough. Okay, now pass the 3 values, double amount, this dot txt amount dot get text, double dot parse dot, double IR interest, this dot txt interest rate dot get text. Okay, now int years, integer parse int this dot txt duration dot get text. 1 minute guys, I have severe cough and it's the problem, I'm sorry for that. Okay, now create loan object. Loan is equal to new loan object. So we pass amount, IR, duration, years. Let me see the parameters. Loan. Okay, we have duration, IR, and amount. Years, and amount. Now we build the table. Okay, loan dot build table. This will do all the schedule. Okay, now pie chart. Okay, in the pie chart we will create a observable list. Okay, and make it store payments. Okay, list, or say chart data. Okay, this is our observable FX collections dot observable array list. Okay, and we need to calculate two things. Percentages, double IR paid is equal to loan dot get interest paid. Okay, divided by loan dot get total paid and multiply by 100. Double capital loan dot get amount. So we already have amount here. Amount divided by loan dot get total paid multiply by 100. These are the percentages to draw the pie chart. We pass these two values. So new pie chart data, that is interest and IR paid, and this one is new pie chart dot data, that is capital and capital paid percentage. Okay, now we have this ready. Let's change it, make it pie chart dot data. Okay, we already have created pie chart, so we will pass this data to the pie chart. So pie chart dot set data and chart data. This will show the data to pass the data to the pie chart and draw the pie chart. Now update labels. Okay, this dot lbl interest does set test string dot format and percentage 0.2f, and we pass it loan dot get total interest. Okay, this dot lbl payment dot set text, and let's store loan payment, private double monthly payment. Okay, we store the monthly payment here, monthly payment, update the reference used. Okay, now add another getter method, public double get monthly payment, return this dot monthly payment. Okay, so this is available here now, string dot format and percentage 0.2f. Let's set the dollar sign. We can use currency instance for the portability. Loan dot get monthly payment. Now this dot lbl total paid dot set text and string dot format $sign percentage point to f and loan dot get total paid. Okay, let's check it. What happens here? Oh, message. Okay, let's run it. This is our application and we'll run it. Okay, so let's say we took 10,000 at the rate of okay, we need to update these labels. Scene builder, and let's update the text. Loan amount is okay, and this is interest rate, and this one is for duration. Okay, let's save it. Okay, overwrite. Okay, and let's try to run it. If something changed in FXML due to overwrite, we can edit it. 10,000, interest rate 5, and let's say 5 years. Calculate. Okay, now we need to update because overwrite change it. FXML buttons, this is button and ID, and it remove the actions on action. And what happened? Okay, let me check the function names. Let user handle calculator handle exit. FXML handle exit and on action handle calculate. Okay, let's see if it runs fine. 10,000 5. Okay, what is wrong here? Java scene PieChart observable flatly because it's null. Okay, reference problem. Chart, and this is PieChart. Oh, this is PieChart. Okay, 10,000 5. Okay, that's it, guys. This is our loan amount. Interest rate is 5 and duration is 5 years. So we have calculated this is total interest paid and this is total paid and this is monthly payment, and this is our pie chart, and we can change the amount. Let's say 10,000, 6%, 5 years. So it will change, automatically update, and you can put any other amount. Let's say 55,000, and let's say this 3 and 5 years, and this. It will automatically calculate everything. Okay, now we go and work on the schedule. Okay, so everything is here. Save it. Don't override, we have to do it again. Okay, we need to add table. Okay, let's change the size of this. Okay, location, layout, and This is our anchor pane. Anchor pane 800. Let's make it 800. Okay. Now controls table view. Table view is a very powerful control. Okay. This will display over casual. Let's delete this. Delete. We will programming it. We will add the columns by coding. Okay, let's name it. Table. Let's test table. Okay. Save. Okay, override. And let's see if we retain things or we have to update again. Okay. PieChart. FXID. Table. And buttons. Okay, no, this time they retained it. Okay, let's go to loan controller. Okay, create reference at FXML private table view table. Okay, now let's build and configure table. Okay. Okay, we need to add 6 columns. Okay, columns, table, column. Okay, and this is 1 minute. Okay, so let's create columns and we pass payment string, and this is called month column is equal to new table column, and we pass heading name, let's say month. Okay, and next we will set the cell value, month column dot set cell value. Set cell value factory and new property value factory, and we map the month. Let me recheck the field names. Okay, these are our field names. Let's copy these so we avoid confusion. Okay. Okay, now we can copy this. We need to change this thing. It is integer for the binding, and double, all are double. This is balance column, old balance. So we can copy this. Similarly, we will add the remaining columns for the table view. Let's create other columns. Okay, this is balance column let's say balance, and this will become old balance and balance column, and change it to double. Copy paste to save typing. Okay, this will become interest payment and interest. Let's follow the naming convention. And this will become payment column. Payment. This is monthly payment. Payment column. And field name payment. Okay, this will become interest paid. Interest column. Interest paid. Interest. Interest column. And this will become capital paid. Capital paid. Capital column. And field name capital. And the last column, new balance. New balance column. Okay, remaining balance. Okay, remaining. So 1, 2, 3, 4, 5 and 6. Over 6 columns are ready. Now we add these columns to the table view. Okay, table dot get columns dot clear the previous column. So when we rerun the program or calculate another loan, the column will be cleared. So this table dot get columns dot add month column, and copy paste 6 times. 1, 2, 3, 4, 5. It becomes 6. So next is over balance, then payment, and then interest, and then capital, and this is remaining new balance. Okay, over columns are added to the table. Now 1 minute. Now fill the table with data. Okay, we have the loan object and we get the payments, and we use, let's say, for each statement. Okay, so payment and lambda expression, just add the table dot get items dot add payment. This will fill over table. Okay guys, so I think we are done for the table view. Okay, now change the size. We added the table view, so expand the width, your height of, let's say, 800. Okay, now let's run it. Okay, we are good to go. So let's add values. 20,000 and let's say 7.5, and let's say for 5 years. So let's calculate. Oh, that's it guys. I think we need to fix the formatting for the 2 decimal place. Rest of everything is working good. I think something is wrong with the calculation because it's supposed to decrease. Okay, let me change it. Okay guys, for formatting we need to add cell factory. So balance to format the cell, set cell factory and cell to new table cell and update item. Okay, we need to update value here, so we will pass set text string dot format .2f. let's make it dollar and a double value. This will format over decimal value. Let's use it for the other columns too. This is old balance, this is old balance. Okay, balance column and payment column, and now interest column, and now capital paid, and then we have new balance. Okay, I think we are done now. Let's run and test. Okay, 20,000 and 7.5, let's say 5 years, and calculate. So our values are formatted now. So we have here starting from first month and all the schedule is printed here. So all the values are perfectly working now. That is the application. So let's say 20 years, and we calculate it and see our chart dynamically update and the chart also updates. For 20 years there are 240 payments, and we print every payment schedule for the 20 years. We can enhance it to display yearly schedule. We can also add functionality to export it to CSV or PDF file. Thank you guys for this video, and see you in the next video. I am going to make the same calculator in Visual C# and VB.NET and also JavaSwing. I have plans to make it an app and post it to Google Play Store. Let's see what happens. Thank you. See you in the next video.